Welcome to a review of surface area. So we're going to be finding lateral areas, surface area, and volume for a prism, a pyramid, a sphere, a hemisphere, a pyramid, what I forget, a cone, and a cylinder. Right? This is in the notes I gave you. Right, so let's review through the formulas, and then we'll find the surface area. Right? And each one has a slightly different formula. Right, so this TA here, that just means surface area. I prefer usually when I say surface area, I mean all of the surface area. Right, so the surface area for a prism, this is a triangular prism, is going to be the 2 times the area of the base, because there's 2 of them, right? We have 2 triangular bases there. And the triangle has to be the base. So some of the errors students are making with the triangular prism is they're not always making the triangle the base. They're making any old side like the rectangle a base, and can't be, right? The sides of a prism have to be rectangles. So any side that's not a rectangle must be a base. All the other sides will always be rectangles, or in the case of an oblique prism, parallelograms. Right? So for our surface area formula, we're going to have 2 times the area of the base plus the perimeter times the height of the prism. And I thought I think I did, and I must have accidentally erased it. Let's see if I can clone that. Clone. There we go. Let's put that over here. And you have that in your notes. It's gone from mine. The lateral area is just the perimeter times the height. Right? It's the area around the prism, right? Not including the bases. So it's the perimeter times the height. And then the volume is the area of the base times the height. Okay, so let's find each of those things. Right? So this is our base. It is an isosceles triangle. So this one is also 5 centimeters. In an isosceles triangle, the height of the pyramid, or the altitude here, is always going to be perpendicular to the base. But not only that, it divides this into 2 congruent parts. Right? So that means each one of them is half the whole base of the triangle. So it's unfortunate that we use the same word to mean 2 different things. This is little b, the base of the triangle. Big B is the area of the whole triangle. So the whole base of the triangle is 8. However, this portion that makes up a right triangle is 4. When you're calculating using Pythagorean theorem to find the height of the triangle, the altitude of the triangle, make sure you use sides in a right triangle. The 8 is not a side in the right triangle. Likewise, when you're finding the area of the base, make sure you use sides in the whole triangle. So 4, for instance, is not the base, or side or the base of that triangle. 8 is. Okay, so be careful. Make sure you're using the right values. Right? So here, this is, actually let's put big H there for the height. This is little h for the height of the triangle. So we can use Pythagorean theorem here. H squared plus 4 squared is equal to 5 squared, and you might recognize what this is going to be because it is a Pythagorean triple. That's one we've seen quite a bit. Right, so h squared plus 16 equals 25. Subtract 16 from both sides, and h squared is 9, which means that the height of the triangle is 3. So that means the area of the base is going to be 1/2 times 8, the whole base of the triangle, times the height of the triangle, which is 3. Half of 8 is 4, and 4 times 3 gives us 12 centimeters squared. For the perimeter, we just add up the 3 sides of the triangle. Right? So that would be 5, 5, and 8 right here. I'll even mark it over here as well. Right? They're exactly the same in both triangles. So 5 plus 5 plus 8, which is going to give us 18. And then the height of the triangle is the distance between those triangle bases. It's also written right up there. It's 16 centimeters. Nothing is going in the lines where it's supposed to go. keeps going a little bit below. There we go. So there we have all the values we need to calculate out the lateral area, surface area, and volume. Right? I have some space below. You have some extra space on your notes as well as you can use the back side. And so, but I'm going to try not to crowd my work up too much here. So the lateral area here is going to be the perimeter, which is 18, times the height of the prism, which is 16. Okay? And so that's going to give us 208 centimeters squared for the area of those three rectangles that make up the sides of the prism. The surface area, we're going to take twice the base, so our base is 12, so 2 times 12 plus the lateral area, the perimeter times the height. Since we already know what it is, rather than writing plus 18 times 16 again, why don't we just write 208, because we know that's what it is. So our surface area is going to be 24 plus 208, or 232 centimeters squared. For the volume, just take the area of your base, which is 12, times the height of your prism, which is 16. So 12 times 10 would give me 120. 12 times 6 would be 72. So 120 plus 72 is going to be 192 centimeters cubed. So I just kind of did that one in my head. And so volume looks at how many of those bases could 1 centimeter high could just, if you stacked them all up, how much area would you have altogether? Or how much space is there inside that prism? So the amount of space in the prism is 192 centimeters cubed. We're measuring the inside. Surface area measures the distance around, measures the outside, measures the amount of area on the outside. All right, so now we're done with the surface area and volume for our prism here. The triangular prism seems to be giving students the most grief. Either number one, they forget it's a triangular prism and they make the base a rectangle. That's wrong. Or they forget to find the altitude of the triangle and just take any two sides. Well, that's wrong, because your base and height in your triangle have to be perpendicular. So if I were to multiply, for instance, 8 times 5, that would be very, very wrong. Those are not perpendicular measurements, and they would not give us the area. As you can see, our area is definitely not half of 40. Other mistakes students are making, they mistake the height of the triangle, the altitude of the triangle, with the height of the prism. Two different things. Those are some of the main things I'm seeing so far. So make sure you solve this carefully and review your notes when you're working with surface area prisms, especially triangular prisms, if this problem is giving you a little bit of grief. All right, so now we're moving on to the pyramid. Right? So the pyramid surface area formula, we only have one base this time. And since our sides are triangles, not rectangles, it's going to be 1/2 the perimeter. And we don't want the height, right, because we're measuring the outside. And the height is different than the outside. Height is inside, slant is outside. The lateral area is just the same as the surface area, just don't include the base. So 1/2 perimeter times the slant. So let's add slant there because that's missing. And then volume is very similar to the prism. Base times height, except it doesn't hold as much. It only holds a third as much because it slopes inward. So 1/3 area of the base times the height. This time we use height. We're given some of these things. We're given the slant. This is on the outside. Ooh, not very straight. That 10 there is on the outside. Closer. Right, and so that measures, well, let's just put it right there. Close enough. That's measuring, that 10 there is our slant. So we're going to use that for surface area and lateral area. But we're going to need to find the height. Right, so this isn't going to be too difficult because this is a square pyramid. And the slant is the same no matter what direction I go. Had this been a rectangular pyramid, we'd have two different slants. Right? We saw that earlier in the pyramid lesson. You have one slant for the two sides, the two triangular sides that are opposite, opposite the length, and because the width is not the same, you have two more that are opposite the width. Right? And so if you need any review on having two different slants, make sure you review that particular podcast, or watch that whole Nearpod lesson again if you'd like. Right? So we're going to have to use Pythagorean theorem to calculate out our height. The distance from the edge to the center is going to be half this value, right? Because that vertex is directly above the center, so this is 6 centimeters. As a matter of fact, no matter which way I went from the center out, it's going to be 6 centimeters because this is a square pyramid. Right? So to find our height, we're going to take 6 squared. I guess I'll just do that over here. 6 squared plus our height squared. That's our height, and I really should use big H. Big H is equal to our slant squared, and our slant squared is 10. So that's 36 plus H squared equals 100. Subtract 36 from both sides, and so H squared is equal to 64, which means the height is 8. And actually, this is the same as the 3, 6, 5 triangle in the previous problem, multiplied by 2. So it's the 6, 8, 10. So this is 8 and 10 centimeters. Now to find the area of the base, remember this is a square. Don't just say one side is the area of a square. No, no, no. Right? The area of a square, well, since this is a square, I'm going to move this down just a little bit. So if this were a rectangle, this would be length times width. Since it's a square, the length and the width are exactly the same, so we also could say side squared. However you solve it, it's going to be 12 squared, or 12 times 12, which is going to give you 144 centimeters squared for our base area. For the perimeter, you just add the 4 sides together. Since they're all 12, it's going to be 4 times 12, or 48. My 12 looks like an R. It still looks like an R, but you make it look better than mine does. All right, so 48 centimeters. All right, so now let's find the lateral area, surface area, and volume. Now that we know our perimeter, our height, the area of our base, and our slant height. So the lateral area, actually, let's do the lateral area first. That's going to be 1/2 the perimeter, which is 48, times our slant, which is 10. So half of 48 is 24, and 24 times 10 is going to give us 240 centimeters squared. For the surface area, just add in the area of the base to that, right? Because it's the half the perimeter times the slant plus 1 base, right? Because half the perimeter times the slant gives you the 4 triangular sides. If you want the 5th side, just add in the base. So that would be, the area of our base is 144, so 144 plus 240 gives us 284 centimeters squared. For the volume, it's going to be 1/3 the area of the base, so 48 again. But this time we're going to use the height because we're measuring the inside, not the slant. So that's times 8. And so 1/3 of 48, 3 goes evenly into 48, right? Because 4 plus 8 is 12, and 12 is divisible by 3. Therefore, 48 is divisible by 3. Oh, that little trick there only works for 3s. So 3 goes into 48 16 times. So that would be 16 times 8. Well, 16 times 4 would be 64. And 64 times 2 would give me 16 times 8. So that's going to be 128. Or I could have done 8 times 10, which is 80, and 6 times 8, which is 48, and 80 plus 48 is also 128. So that's 128 centimeters. This time it's cubed. And there we go. Right? We found surface area, lateral area, and volume for the prism and the pyramid. If there was any part you did not understand or want me to review or do additional problems with, just put a little star by it, and I'll do that in class. All right, 2 down, 4 to go. But the next 2, so you have them on one page. I spread them out. Otherwise, my writing was kind of crammed. The next two are the easiest of all. That would be the sphere and the hemisphere. So the surface area for the sphere is 4 pi r squared. There is no lateral area because there are no sides. It's just that round area. There's no base. There's just surface area. For the volume, you take 1/3 times the surface area. Okay, because remember I showed you how to find the volume using pyramids, and the base of the pyramids, they went all the way around the sphere. So the base of the pyramid was the surface area of the sphere, so it was 4 pi r squared. The height of all of those pyramids was the radius, because it went from the edge to the center. And because those are pyramids, the volume is going to be 1/3 as much. And that gives you the formula, in case you ever forget any part of this formula, gives you the formula for the volume of the sphere, 4/3 pi r cubed. Make sure you keep surface area and volume straight. All right, so our surface area, let's just calculate that out. The surface area is going to be 4 times pi times 9 squared, which would be 4 times pi times 81, which would be 324. So that's 324 pi centimeters squared. For the volume, that'll be 4/3 times pi times 9 cubed. So 9 cubed is 729. 729 is divisible by 3 because 9 was divisible by 3. Matter of fact, it's nothing but 3's, right? 6 3's to be precise. So 729 divided by 3 is going to give us 243. And let me put that over here. I'll go this direction. So that would be 4 times pi times 243, which means our final volume is going to be 972 pi centimeters cubed. Here we go. And we're done with the sphere. We did the sphere a while ago before we did any of the other surface area formulas, right at the end of volume. The hemisphere, let's do the volume first. The volume is exactly half. So this is going to be 2/3 pi r cubed. Right, so let's find the volume. That's going to be 2/3 times pi times 11 cubed. 11 cubed I do not know off the top of my head. So 11 cubed is 1331. And now I'm going to make a point of remembering it because it's a palindrome. Look at that, 1331. What a nice number. Not divisible by 3 because 11 is not divisible by 3. So let's just keep this as a fraction. This is going to be 2662. Oops, somehow I lost a 6. 2662 pi thirds inches cubed. The surface area, it's not exactly half because of the circle base, so we have to add another pi r squared. So this is going to be 3 pi r squared. So we have 3 times pi times 11 squared, which is 3 times pi times 121, which would be 363 pi inches squared. And there we go. And we're done with the sphere and the hemisphere. And likewise, if you have any questions on those, let me know. Last but not least, the cylinder. Right? So let's do the surface area first. The surface area is going to be the area of the two bases. So that would, and actually let's use our factored formula. Right? So that would be 2 pi r, factors out, and it leaves an r plus an h. The lateral area is just the circumference, which is the length of the rectangle, and the width is the height of the cylinder. So that's going to be 2 pi r, oops, horrible looking 2, because that's the circumference formula, and then times the height. The volume is the area of the base. It's a circle, so it's pi r squared, and then times the height. And there's our three formulas for the cylinder. And so let's calculate that out. We do have to find radius, though. Make sure you don't use diameter. That is a mistake I am seeing a little bit. So the diameter is 15 meters. That line going across tells you its diameter. Don't assume radius. The radius is going to be half that, 7.5 meters. All right, so our lateral surface area, I'll put LA, is 2 times pi times 7.5 times the height there, which is 43. I'm going to multiply that 2 times 7.5 right away, because now that would be 15 pi times 43. And now I want a calculator. I'm just going to put the pi first. 15 and 43, which will give us, well, I could do 10 times 43 is 430. Actually, I will. I don't need the calculator. So 10 times 43 is 430. And then 5 is half of 10. Half of 430 is 215. So 430 plus 215 is going to give us 6, 4, and now is 0, right? No, 5. 6, 4, 5. Because it was 430 plus 215. 6, 4, 5. Sometimes I need to see it. 6, 4, 5 pi, this was meters, meters squared. Right, for the surface area, let's use our factored formula, would be 2 times pi times 7.5, because that's going to become 15 right away again. And then 7, now we're going to have a fraction, a decimal, 7.5 plus 43. No, I want a calculator. Is going to give us, let's just multiply the 2 and the 7.5. So that's going to be 15 times 50.5, which is, oops, and I hit something in wrong. 15 times 50.5, 757.5. Oops, 0.5. 0.5, don't forget our half. 0.5 pi meters squared. And then last but not least, I wonder if this needed 3 pages. I think I'm okay. I think I have enough room for volume here. The volume is going to be pi times 7.5 squared times 43. Kind of squeezed that in there. So I'd probably write that just a little bit nicer. So we're almost done. So volume is pi times 7.5 squared times 43. That does look nicer. All right, so actually I don't need to write V again. The 7.5 squared, I think it's like 56.25. I've seen that one a little bit. Yes, 56.25. So this would be pi times 56.25 times 43. And now let's use a calculator after we shove this one over a little bit. Equals, so times 43 is 2418.75. So 2418.75 pi, and this was meters cubed. That's a pretty big cylinder. Maybe it's like a storage tank or a silo. All right, the last one is the cone. So the surface area of the cone, let's use our factored one, right? So because it slopes in, right, it's not going to have that 2 there. It's going to have just pi r. And we don't use the height, we use the slant. So this is going to be, and well, we didn't really need to have a space for, well, we added the radius, and this is the height. But we should probably, I guess I should write in red. That one is red. We should probably put a space here. So squeeze that over there. And height. And then slant. Okay, we'll need those measurements. All right, so surface area is pi r times r plus L. We use the slant because we're measuring the outside. The lateral area, right, is just going to be the circumference times the slant. but since it slopes in, and so it's like it has half the area, it even looks like a triangle, instead of 2 pi r, it's just going to be pi r. And instead of height, it's going to be slant. And then the volume is the area of the base times the height, but it only has 1/3 the volume of the cylinder, so it's 1/3, come on, almost done, pi r squared. And it comes up, come on, r squared times height. We're given the radius already, that's 12 inch, 15 inches. We need the height. And I'm trying to think where I want to, I guess I'll put it right over here next to the green. So we have 12 squared, radius squared, plus height squared, and that's the height of the cone, equals slant squared, or 15 squared. So that's going to be 144, trying to squeeze this in somewhere, maybe over here. 144 plus h squared equals 225. Come on. Yeah. Subtract 144 from both sides. H squared is 81, which makes the height 9. So all of these were nice, pretty Pythagorean triples. Let's real quickly find all three things here. So our lateral area is pi times 12 times 15. So that's going to be 120 plus 60, 180. 180 pi inches squared. For the surface area, we have pi times 12 times 12 plus 15. So that's going to be pi times 12 times 27, which is 324 pi inches squared. And we have one last thing, and where do we put it? Volume. I guess I should have used one extra slide. I'll try and write small, put volume right here. So 1/3 times pi times 12 squared times, want the height now, 9. 12 squared is 144. So we have 1/3 times 144 times 9. Instead of taking, they're both divisible by 3, I'm going to divide 9 by 3 because that's even easier. So we have 3 times 144. So that's going to be 432 pi inches cubed, and we're all done. And except for the fact that it's a little bit crowded, but I can move that over there, and now it doesn't look so crowded. Everything looks great. All right, so you should have this in your notes. That's the end of surface area, although we'll be using surface area and volume in our next lesson, which is modeling with geometry. All right, thanks for watching. Bye.